Packard puts it on their monitors, which is our computers, that is your computer. So I know the output from the oximeter is digital. So you just need to get the code, you just need to get the type of format. And then plug it into one of your computers that you're going to dedicate to this little project. It can be something smaller than that, but it has to allow the input. And if you're lucky, you can get off one of those side ports, those USB port. And it could be that's what you want. And you may, if the standard oximeter doesn't have a USB port, chances are there's somebody who does. And if you write them, they'll probably since you're doing a school project, they'll probably loan you one for a year, I would think. With her signature, not his.
Right.
Teacher
patience.
But if you get it RSB 222, then you got a reading, and then you got real time. Now, then you got a feedback. You got to have some feedback adjustments in the oxygen. Now, the question there are whether you want to actually adjust a valve. And in that case, there are valves that are RS-232 driven. Another way of doing that is just clicking something. So you visualize oxygen going through that many stages, that many orifices. And you just click from one orifice to the next, openings in the line. But that's one way of doing it. So you have fixed oxygen on one side, all you do is change the orifice between the supply side and the patient side. And you go one step at a time. That's less sophisticated, but it's also cheaper. And it's probably, for this, maybe all that's necessary. That you just go from a half a liter a minute to a liter a minute, minute and a half a minute. You just have 5, 6, 7 different digital, discrete oxygen delivery levels. Now, the only problem with that is that you could get some cycling. You'll cycle up, and you click to a lower one, and it'll cycle down. And you click to the upper one again, and you just be cycling back and forth. You won't smooth into a steady state. You'll actually cycle. If you could get a valve, a continuous valve that would control it, you're probably better off using that than just deciding how to control it. I don't know that much about those types of valves, but
so you're thinking of a motorized valve that we could have the computer send like an input to, turn it open or close.
a certain amount, 1/4 of a turn. I mean,
It might take much probably. I don't know how these are built, but pretty much motorized or magnet driven, or I don't know how they would make those.
if you go to the hospital and look at how they control the valves, go to the valve, turn it all the way off. There's a little meter above it that says how many liters a minute. They still have those, don't they?
Oh, yeah.
See how many turns you have to make before it goes from the bottom to the top reading.
And then calibrate it.
Like how many turns per liter?
So the then you find the diameter of it at the end.
Yeah, then you find the diameter at the end, and that's what you need to look for, is to open the valve up and look, see what that opening, to see what size you need. The question would be, well, I don't know, how sophisticated do you think? Do you have any money? That's a stupid question.
Right. Teacher.
You could get very sophisticated to measure the oxygen.
Yeah.
I don't know how I'll have to
Least
look at,
invasive.
like the oxygen blenders and the ventilators and such, how those work. They're different than the operative stuff.
Mhm.
I've never looked at the mechanics of.
Would the anesthesiologists have that they're gonna talk to?
They wouldn't understand it.
Probably not. You know, to most of us, this is a black
It's just a-
box. You turn it to 3 and it's 3.
Geller.
You turn it to 1 and
Yeah.
it's 1.
Geller, is his name Geller?
Yeah,
He-
he's one of the
He's an
anesthesiologists.
engineer. too.
Is it?
He might know a little more.
Okay.
Harvey, is it Harvey?
Yeah, I heard it.
Yeah. He's actually, he was an engineer for he's pretty savvy.
So what we're gonna want to do is have the oximeter plugged into the computer, which
Mhm.
will basically analyze it and then output the diameter, I guess, that they wanna make the valve.
Well, that's not the way feedback control works. You just feedback, I'm gonna open.
Mhm.
And if you're way off, I'm gonna open a lot. If you're way off, I'm gonna open a whole lot.
Mhm.
In other words, you feedback the change is proportional to how far off your goal is. And you start off with the thing turned off, and you have a goal, so it starts off reading 50% saturation, so it opens all the way. And then when the patient comes up, then it starts ratcheting back. That's feedback control.
Mhm.
Now, whether this saves money in the hospital will depend, once your system is working, is determining whether the oxygen used was substantially less than it would have been had you chosen
Mhm.
a fixed setting.
Yeah.
Or do you get the patients off faster? Because if he wants to take somebody off oxygen, probably turns it off, and the system's, the physiologic system is fairly fast turnover, so within 10 to 15 minutes, 15 minutes?
15 minutes.
You know whether that patient flies or not. And what you should learn out of this is what control systems are, what half-life is, what it means. Because you know what a half-life is?
They're just in chemistry right now.
Yeah.
So you said of insulin, the half-life was 3 to 5 minutes. So if you input your insulin into somebody within 6 to 10 minutes, that's when it has to act.
Well, the half-life is when it's half what it was at the
When it-
beginning.
Yeah.
So if the level started here and it eventually went to here, it's halfway between those two at the half-life. So T1 is where you're half the concentration. And it normally takes, at 1 half-life, you're 50% done. At 2 half-lives, you're.
25%.
No, it's not.
Doesn't have work that way.
Doesn't work.
Right, it's half of that.
25.
So,
No.
that 2 halves, so you start off, whatever.
All I
it's
remember is after
100,
about 5 half-lives.
then it goes down to
It's
50.
about 5 half-lives,
It's almost
it's
gone.
about 90-some%.
Yeah.
Another thing to Google is half-life and how to interpret it. Because I can give you a lecture on half-life, but I forget exactly the number of half-lives it takes to get out to 90-some%. But it's a nice thing to know, because it's a useful tool, because it's gonna help you with this project tremendously.
No, I'm gonna
If
go
you're
sit and
half-
do this.
So he waits 15 minutes, so if 5 half-lives is 15 minutes, then it's 3 minutes. I bet you wait past that, I bet its half-life is probably in a minute or two.
Right.
But all the way down to here?
I'm sure someone's looked at that, but would have to look that up.
You need to know the half-life, because you can't be making, you don't want to be making changes real fast. You don't want to even be close to the half-life, because if you do, you're going to induce cycling. If you induce cycling, you're not going to save any money. Or lives, because you could be cycling way down here. The project that you're describing could get bogged down in the computer interface of the computer controlling the oxygen, or the oximeter talking to your computer. Now, it is, because this thing is so fast, you don't want a nurse sitting there taking a reading.